Hello everyone and welcome to the NPTEL course on pharmacognosy and phytochemistry. Welcome to the session on tannins. In the previous session, we have studied few examples of tannins. Just to summarize, we studied cases of hydrolyzable tannins which included your nut galls, amla, pomegranate, myrobalans, both harada and bahida, as well as the Malabar quinoa. In this session, we will learn about condensed tannins. Do you remember condensed tannins are the category of non-hydrolyzable tannins, and they have more of either a fluoroglucinol type or a flavanol type nucleus. In this particular session, we will study pale and black catechu, which are the examples of flavanol type of condensed tannins. So let's start with the pale catechu. Now pale catechu, often referred to as Gembir or pale catechu or catechu, is a aqueous extract. Now unlike other drugs that we have studied so far which contain the whole plant part, we refer to as organized drug. In this case, pale catechu is an example of unorganized drug. That means the drug has no cellular units in that. So what we take of this plant is, the tree is called as Uncaria gambier. So from this young twigs, the aqueous extract is taken, dried to develop a hard stony material, and this material is referred to as pale catechu because of its paler color than the subsequent drug that we will be dealing, that is your black catechu. The pale catechu comes from erstwhile Malayan region. Now this includes Malayan countries such as Indonesia, Malaysia, Sumatra, Borneo, or even Singapore. These are the regions where the plant occurs very commonly. So what is done is, in order to get this extract, you cultivate the plant generally from the seedlings, and at its second year, when it has developed sufficiently young twigs or young shoots, you collect the first crop of it. Now the good part is, after you collect the first crop, the plant will still keep on growing new shoots. So every year you can collect fresh produce, and it is said that you can collect it till 20 years of the plant, and the best produce is thought to be somewhere around 8 years. So that's where your tannin content or your extract which comes from this plant is maximally. So this plant, the fresh twigs or the young shoots are cut off, they are collected, they are put together in a metal drum with about 3/4 of water. So once that is submerged nicely with 3/4 of water, you can start boiling it. Now this is boiled for a period of about 3 hours. When it is boiled, you will see that gradually you will see a greenish brownish color extract coming out. Now since you have this material like your tea powder often interferes, so large wooden forks or meshes are taken, and this raw material or the cellulosic material is moved towards side. Now as you move that material towards the side, you will see that that also takes along some juice or extract to it. Now if you want to increase the efficiency, this material is pressed off with those same wooden forks so that the juice flows back into the vessel. Sometimes this mark is also washed, so you can add additional water on this mark, and whatever is there, the washings are also allowed to flow in the container in such way that the plant material, from the plant material you can extract maximum tannins, and all these tannins go on in your vessel. Now once you have the extracts and all the washings being done in the vessel, you could concentrate it. Now this concentration is done for more than an hour till you get a very pasty, syrupy consistency of a liquid. Now this thick yellow viscous liquid or paste is then put in troughs, okay, like a wooden troughs, and this wooden troughs are actually kept in some cold stream of water. What happens is, as the juice is hot, it is still fluid, but the moment you put it in a flowing stream of cold water, it starts thickening. This is allowed to thicken, and as it has, as it gains a good pasty consistency, this is then put into trays or drums or even vessels. So once that is done, on complete cooling, it will solidify. Once it solidifies, it is cut with the help of blunt wooden knife to get what are called as cubes of catechu. Now this pale catechu is very good source of tannins. So if you see the chemical composition, it contains monomeric, that is pseudotannin, catechin, almost 7 to 30%, depending upon the age, depending upon the geographical location. Changes might happen, but on an average it has about 7 to 30% of catechin. So much so that if you take it, break the catechu block and mount it in lactophenol, you would even see the catechin crystals. Apart from that, it also has polymerized catechin. If you remember, condensed tannins are formed when this flavanol unit of catechin starts polymerizing it in itself by forming numerous units. So this polymeric units are called as phlobatannins or catechu tannic acid, because the monomeric unit is catechu. So this drug has about between 25 to 55% of phlobatannin. You can call it as catechu tannic acid. Now it has one more interesting principle, and that is called as Gambier fluorescein and catechu red. Now Gambier fluorescein, as the name indicate, it has a little ability to fluoresce. Catechu red is more of a phlobaphene derivative, and quercetin is a flavonoid derivative. Apart from it, it contains indole alkaloid. You can see the structure of it. So this is the indole moiety in the indole alkaloid, and this is called as Gambier tannin. Now Gambier tannin is also a principle responsible for fluorescence of the pale catechu extract. Now this being a condensed tannins, you can evaluate it using numerous methods. Why to evaluate it? Because in market, the pale catechu and black catechu are often admixed with each other, and that is the reason it is often crucial to identify pale catechu. Now how do you identify pale catechu? So if you break it, and as I told you, if you mount it under microscope with little lactophenol or mountain solution like water, simple water, you will see circular crystals of catechin under microscope. Apart from that, if you see a compound called as Gambier tannin or Gambier fluorescein, that can also help you identify pale catechu. So how do you identify, how do you see this fluorescence? Now we know this compound is a indole alkaloid, and alkaloids in their basic state, that is alkaloids in their unionized state, have a very excellent solubility in non-polar solvents. So what do you do here? You take your pale catechu. Now this pale catechu basify a bit. You can basify it with ammonia, you can basify it with sodium hydroxide, or you can even basify it with potassium hydroxide. The intention here is to create a basic pH, so my alkaloid remains in an unionized state. The moment it is unionized, its solubility in water drops in, but its solubility in organic solvent is enhanced. And as a result, if you take this catechu alcoholic extract and partition it using petroleum ether, the petroleum ether layer will happily absorb. That is, your Gambier tannin, that is the alkaloid, will partition into the pet ether layer. This pet ether layer, if you see it under UV light, you will see a nice green fluorescence. The indication of that green fluorescence tells you that the sample that you have got is of pale catechu. Now another interesting test to identify your pale catechu is test for chlorophyll. Now in this case, when you saw the raw material here is your twigs, that is the fresh leaves and fresh stem. If you see fresh leaves and stems, that is the apical part of our tree, they are greenish in color, and this green color is attributed to a pigment called as chlorophyll. Now chlorophyll is a non-polar lipophilic pigment. So what you have to do is again take a pale catechu powder, crush it nicely, or take a pale catechu slab and crush it nicely. Once in the powdered state, you extract it with organic solvents such as chloroform. Generally chloroform is used because chlorophyll dissolves readily in chloroform. You will see most of the pigments including your chlorophyll will dissolve in the chloroform layer. Now filter it so that the catechu doesn't interfere, and to that filtrate, if you evaporate in a white color or a clear dish, you will see a greenish color residue. This greenish yellow residue is due to the presence of chlorophyll and oxidation products of certain carotenoids. So this is also another unique test which will help you identify pale catechu. The other tests which it will obey are definitely your vanillin hydrochloric acid test for condensed tannins, as well as the matchsticks test which we studied previously. Now applications, where is pale catechu used? Now pale catechu, owing to its very high content of catechin, is used as a local astringent. So for mouth ulcers it is used. It can be used even topically in creams. It is given for patients suffering from diarrhea as a general astringent, and in some countries, especially the Malayan countries where it commonly grows, it is given with betel leaf. Now a large amount of it initially was used in tanning and dyeing industries. We know your tannins are very good pigments which have a staining ability, especially for proteinaceous fibers. So this has been used again classically for dyeing and tanning industry, again for converting your animal hide into leather. Now another species what we study is a little Indian species called as black catechu. Black catechu, if you have to say the Indian context, you remember katha or katha, which is there in your pan masala, is the same black catechu I am referring to. So it's often called as kach, black catechu or katha. It comes from a plant, that is your, again this is an unorganized drug. It is coming from the aqueous extract. So the drug here is not a cellular one. The drug here is the aqueous extract which has been obtained from the heartwood of Acacia catechu. Now this belongs to the family Leguminosae. As compared to your black catechu, where you used your young twigs or young shoots, let me point out that in this case it is the heartwood which is used. So if I have to tell you what heartwood is, if you take a tree trunk and dissect it, the outer part of it is called as bark. So this is the bark. This is what we call it as the sapwood, and this is what we call it as the heartwood. So the heartwood is the oldest part of the wood and it's rich in secondary metabolites. So your black catechu or katha comes in from the heartwood of Acacia catechu tree. Now this is again grown abundantly in the deciduous forest as well as cultivated in Punjab or regions from Punjab to Assam, Madhya Pradesh, Maharashtra, Gujarat, Rajasthan, Bihar and Tamil Nadu. Now this being a heartwood, it's little difficult to procure. So once you have a tree which is completely matured, you have to cut the tree completely, or in some cases copicing is done. Let us a little stump is left over the ground, rest of the tree is cut off after that particular height of about say 1 to 3 feet. Once this copicing is done, the outer bark is peeled off, then the sapwood is peeled off and the inner heartwood is taken. Now this inner heartwood is cut into finer chips. Why? Because you want to prepare an aqueous extract for it. If you keep the whole wood or log as such, the extraction will not be efficient. So in order to increase the surface area, get more efficient extracts or better rich extracts, you have to chip it and make finer particles of it. This is generally done nowadays with sawmills where you have good advanced cutters. So this heartwood is taken, cut into fine chips, and these chips are then taken and boiled in earthen pots. So this is the traditional method. Nowadays even stainless steel pots have been used, which are nicely jacketed to create a good temperature or heat transfer. So this earthen pots were heated traditionally with the sapwood itself, so that any part of the wood doesn't go waste. Now this process is continued till you get a again syrupy mixture. The good part of it is the chips can easily be separated. So it is strained through a cloth and then poured into an iron pot with continuous stirring. Now why this iron pot, or why is this iron pot specifically put in here, is if you see Katechu, especially black Katechu also, that is rich in condensed tannins. But you remember that condensed tannins react with iron. We saw ferric chloride test. So when you put it in an iron vessel, there are good chances that the tannins will try to chelate and react and form complexes with the iron metal. This happens, and as a result you will get a little darker shade as compared to your previous example, that is your pale Katechu. So this is done for enough time. If you have to improve the color, people often try to give away black Katechu as pale Katechu. So if you want to enhance the quality of it, enhance the color of it, what they do is they keep it in a glass lined vessels where the interactions with the surface is minimum. So in that case, or even in case of stainless steel vessels, you will get a much lighter shade of Katechu, almost matching to that of your pale Katechu. So that is done when the extract is transferred, cooled, and then allowed to set. This is generally set in wooden trays where it almost, after keeping overnight, solidifies. Once it solidifies, it's cut into pieces and sold in market as your kach or katechu. Now this is there with your panwalas, and you will see it as nice cubes or blocks. Now what does it contain is, as compared to pale katechu which had about 7 to 30% of catechin, here the catechin content is much less. So you will see 2 to 12% catechin, again depending upon the source. So this is your catechin, and if you see this bond particularly, if you change it, you get what is called as epicatechin. So you have catechin and epicatechin as monomers. If you remember, these are pseudotannins. They will polymerize to form phlobatannins, which are called as catechotannic acid. So about polymerized particles or polymerized tannins, you will see about 25 to 33%. Now compare that to the pale katechu. Pale katechu had 25 to 55% of phlobatannins, especially catechu tannic acid. Now apart from that, a little difference here is it doesn't contain your Gambler tannin or Gambler fluorescein, but here you have more of this acacatechins, especially the D-L-acacatechin and iso-acacatechin derivatives. In addition to that, this is more rich in gummy matter, and that gives you a good blend or good taste. Coming to the chemical test, if you see, because it is lacking in Gambler fluorescein, the black catechu will not give you a fluorescence test. because it is not prepared from twigs, it will not have chlorophyll. So these two tests are absent in black catechu, whereas the general test for condensed tannins, if you remember, it will obey your vanillin hydrochloric acid test, and it will also obey your matchstick test because it has catechin. The test unique to black catechu is if you treat little bit of this black catechu with lime water, it will form a complex which is more brownish, and if you keep it standing for a period of 5 to 10 minutes, this brownish color will turn into a reddish color precipitate. So it will form a colloidal complex which will be more reddish and on standing. The second one which is more unique here is if you see your condensed tannins, they give you a greenish coloration with ferric chloride. So with iron salts, even your black catechu gives you a green color, but this time the iron salt is ferric ammonium sulfate. Now this, if you add sodium hydroxide, so if you add sodium hydroxide to this, that green color gradually turns into a purplish hue. So these are two tests which will help you tell that whether it's a black catechu or not. Now applications, black catechu is very medicinal, and that's the reason it's given as an astringent, as an antidiarrheal. It is known to cure the disease of mouth and certain bacterial infection, and that's the reason it was actually added to pan. So if you see that panwala applying your black catechu, it's actually medicinal, and its astringent properties kill the bacteria and help fight your mouth odor. Now one more interesting phenomenon if you observe here is the catechu reacts with the lime as well as the areca nut, which we refer to as supari in pan, to give you an interesting red color complex which you will find associated with people chewing pan. They often spit a reddish coloration. Now this is actually a chemical test formed due to complexation. Apart from that, it is being a tannin, it is used for dyeing fabrics, and it gives a nice brown black coloration. So here are few references, the textbook which you can read to, and thank you everyone for your patient listening.